Okay, so today we are learning about lesson 1.3, real numbers and the number line. Go ahead and fill in your name and let's get started. So the warm-up for today, evaluate each expression for the given values of the variables. So we have two expressions given and it asks us to plug and chug. All right, so let's go ahead and rewrite the 2p squared one. So it's going to be 2, p is going to be 4 squared plus 2, q is going to be 3. Now, you have to be careful when you're writing this that the parentheses go in the right spot. Q is going to be 3 squared, okay? Now, PEMDAS. First, let's look for parentheses. I do see the 4 in the parentheses. That is simplified, though. And 2 times 3 in parentheses. So, we have to simplify the 2 times 3, which is 6. Okay, next, exponents. There's 2 sets of exponents. Let's move from left to right. So 2 times 4 squared is 16 plus 6 squared is 36. Okay, addition and subtraction. So multiplication and division. So I only see one multiplication here. It's 2 times 16, which will give me 32 plus 36. And in the end, we are left with 68. Okay, because you are just adding 32 and 36. Okay, next one. I'm going to change colors so you guys don't get confused. 2w plus 3v divided by v squared. Let's go ahead and plug them in. 2 times w, which is 1, plus 3 times 6 divided by 6 squared. Okay, now we can go ahead and solve this or simplify this just doing the top and the bottom separately. So let's go ahead and take care of the top. So we've got 2 times 1. Well, first of all, parentheses. Everything in the parentheses is simplified. There are no exponents. Multiplication and division. I see multiplication here. 2 times 1 is 2, plus 3 times 6 is 18. Okay? On the bottom, parentheses, everything in the parentheses is simplified. Exponents, 6 squared is 36. And so this is 20 over 36. Okay? Now we should simplify this. I see that they're both even, so we can take out a 2. So this becomes 10 over 36 divided by 2 is 18. Yeah, 18. Still even, so we can take out another 2. So this is 5 over 9. And that is the fraction in its simplest form. Okay? All right, let's move on to the next slide. So today, our essential understanding, what you are doing is you are explaining why the sum or product of 2 rational numbers is rational, and that the sum of a rational number and an irrational number is irrational. Okay? And we will go over what rational and irrational both mean. Okay? All right, what is a rational number? First, let's talk about square roots. So 7 squared is 49. So what we can say is 7 is a square root of 49. Okay? Go ahead and underline square root. What I want you to do is I want you to try this. What is the square root of 16, 81, and 100? So for 16, it's 4. 4 times 4 is 16. 81, it's 9. And 100, it's 10. Okay? If you square any of those, they will become 16, 81, and 100. To find a square root, you use what is called a radical, and it looks like this. So, for example, for the ones that we were doing over there, square root of 16 is 4 Square root of 81 is 9. Square root of 100 is 10. Okay? That's how you would write it. All right, so we are going to go and find out the square roots of these. The square root of 64 is 8. The square root of 25 is 5. The square root of this fraction. So whenever you have square roots, just like when we had exponents, we could distribute that exponent to both the numerator and the denominator. We are going to be able to do the same thing here for the square root. So this turns into the square root of 1 over the square root of 36. 1 times 1 is 1, so the square root of 1 is just 1. And the square root of 36, we've already gone over, is 6. All right, and the same thing for this last one. Square root of 81 over the square root of 121. This becomes 9 on the top and 11 on the bottom. Okay, that fraction cannot be simplified. You could obviously turn it into a fraction, but we will not do so right now. All right. What is the value of the square root of 34 to the nearest integer? So let's go ahead and try that. Now, in order to try that, we know that 34 is not a perfect square. What we want to do is find the two squares that are the closest one less than 34 and the closest one above 34. So 34 is right here. The higher square, I know that 36 is a perfect square because 6 squared is 36. And I know that 25 is 5 squared, and that's below it. Okay? Now, 34 is very close to 36, and it's not that close to 25, considering how close it is to 36. So what we are going to say is that the square root of 34 is approximately 6. Okay? Nearest integer. And whenever you draw two squigglies, that's saying it's approximated. Okay? Let's try it for the square root of 14. Okay? Square root of 14. So what I want to do is I want to write 14. The closest one below it would be 9, and the closest one above it would be 16. 14 is closer to 16. 16 is 4 squared, and 9 is 3 squared. So we can say that the square root of 14 is approximately 4. Okay? That is some examples of approximating the square root. All right. What is a rational number? A rational number is any number that you can write in the form a over b, where a and b are integers and b is not equal to 0. Okay? Because if b was equal to 0, it would be undefined. Sorry, I want to write that better. And in this, a divided by b. There we go. All right, so examples of rational numbers. Okay, rational numbers are all the whole numbers, real numbers. Okay, so rational numbers include 1, 2, 3, ... They include the negatives. They include 0. Okay, it includes any decimal that terminates or repeats, a repeating decimal. A repeating decimal would be like 9.3333 and so on, which turns into 9.3 repeating. That's a repeating decimal. Or if it was 7.36, 7.36 repeating. Okay. Yeah. So it's any of those numbers. those are considered rational. Now, what is an irrational number? An irrational number cannot be represented as the quotient of two integers. In decimal form, irrational numbers do not terminate or repeat. So basically, an irrational number is a number like, I don't know, 136.784391117 and keeps on going and never repeats, okay? That would be an example of an irrational number. Pi is an irrational number. 0.10101000. Even though there's a pattern here, it's not repeating, so this would be an irrational number. Yeah, it's basically numbers that are not very nice, okay? All right. Rational versus irrational, okay? So one thing that you guys should know, which is why we did so much with the square roots earlier in this lesson, is if it's a perfect square, it's a rational number. For example, the square root of 4 is 2. The square root of 25 is 5. Any numbers that are not a perfect square, when you try to take the square root of them, you get an irrational number, okay? So the square root of 14, like we calculated before, would be irrational. The square root of 34, which we did before, would be irrational. But the square root of 36, which we know is 6, is rational. Square root of 49, which we know is 7, is also rational, okay? This slide will be your best friend, okay? So what we haven't talked about yet are these three things. What are natural numbers, whole numbers, and integers, okay? A natural number is any number that is positive, and it's like 1, 2, 3, as if you were counting up from 1 all the way to infinity, okay? And if you look over on the right, there's a number line and it gives you all the natural numbers. So 1, 2, 3, going on forever, okay? Whole numbers. The whole numbers are all the natural numbers plus 0. So that 0 is very important. Those are called whole numbers, okay? One way I used to remember it was whole. Think about a 0 is a whole. If you include the whole, you have all the whole numbers, okay? And integers. Integers are any number that is positive or negative that is a whole number, okay? So it goes from -1, -2, to +1, +2, all the way through to infinity in both directions, okay? This is a great example or diagram of the rational numbers, which lie out here, integers and what they include, whole numbers, natural numbers, and then irrational numbers over on that right side, okay? So any irrational number is not a natural number. It's not a whole number, it's not an integer, and it's not a rational number, okay? But integers are all rational numbers, whole numbers are all rational numbers, and natural numbers are all rational numbers. Okay, so use this, get familiar with it, because we will be using this a lot in later sections. Rational or irrational. I want you guys to try and label which ones are rational and which ones are irrational based on this. Okay, so 2/3, that is just a simple fraction, so this is rational. -1, that is an integer, so that is rational. -19 divided by over 100, that is also rational. Any fraction is rational even if it's negative. Pi, we already went over, is irrational. Why is pi irrational? It's a decimal that does not end nor repeat. Okay? 17 divided by 4,573, rational. If you can write it in that form as a fraction, it is rational. The square root of 144, that is 12, okay? And 12 is a whole number, so 12 is rational. Okay? The square root of 113, this is irrational. Okay? Why? Because 113 does not go evenly by any, no number squared will give us exactly 113, okay? This 100 squared, or 10 squared is 100, and then 11 squared is 121, okay? And 113 lies in between there, so it's somewhere between 10 and 11, but it is irrational. Okay, moving on. Inequalities. An inequality is a mathematical sentence that compares the values of two expressions using an inequality symbol. The symbols are less than or equal to, greater than, or greater than or equal to. Okay? Keep in mind, if the mouth is open to the right, it reads as less than, because you're saying whatever's on the left is less than whatever's on the right. Same thing over here, less than or equal to, whatever's on the left is less than or equal to whatever's on the right. If whatever's on the left is greater than what's on the right, that's when you use the greater than symbol, okay? All right, what is an inequality that compares the numbers square root of 17 and 4 and 1/3? So the square root of 17 is an irrational number, but we can approximate what it is, okay? So in your calculators, I would like you to take the square root of 17, which is 4.1231, and it goes on forever, and 4 and 1/3 is equivalent to 4, and then 1 divided by 3 is 0.333 repeating, so 0.333 going on forever. Now, we can already see that 4 and 1/3 is larger because we compared these first two numbers. And since 3 is bigger than 1, we can write it like this. 4 and 1/3 is greater than square root of 17. Okay? It's going to ask you, in this lesson, it's going to ask you to compare a lot of the real and rational and irrational numbers. Order the following numbers from least to greatest. So what you guys have to do is, the first step is to come up with a common form. In this case, I would stick with a decimal. So I would convert everything to a decimal, and you already have 2 of them done for you. You just need to convert square root of 4, which is 2, and that's in decimal form. And now we've got homework for you guys. So go ahead and get started. Good luck, and let me know if you have any questions. Thanks for listening, as always.